Today we're going to talk about interrupts. And one way to illustrate why we need interrupts is this dumb little situation here, right? So here we are in a carrot factory, and what we're doing is we're slicing carrots. So we've got a machine that has a big slicer, and there's a beam break, and we can tell every time the blade passes the beam, that's one slice of a carrot. And the idea is that we want to seal the bag of carrots once we've got 10 slices inside, right? The problem is if I'm doing this and I'm doing something else, like I'm sealing the bag, say sealing the bag takes a second or two, we got to heat seal it, and that takes a couple of seconds, then I might miss some of the slices that are going through, and I might end up with more or less in a bag, and that's bad for business, right? So the idea behind interrupts is it's something in the background that we can set up. It's an asynchronous signal that we can set up to perform a task that is handled by software. So basically, an interrupt request is an asynchronous signal, and an interrupt handler or interrupt service routine is a function that executes as the result of that signal. So whenever that signal occurs, that specific function executes. And this can happen at any time during the normal thread of execution. So the way that this works is during normal execution, we'll have some kind of main program and an interrupt will occur, right? So this interrupt request occurs, and this is the signal. And this request source can be anything like a timer, it can be a physical pin on the microcontroller, it can be all kinds of stuff, right? But what happens is that the interrupt signal, the interrupt request, causes that main thread of execution to pause. It stops executing, and we go and save the current executing context. So all of the stack variables, all of the status variables, the current program counter, all of that is saved onto the stack of the machine so that when we come back to it later, we can restore it and pick up right where we left off in the program. What happens after that is that we look up the interrupt service routine that's associated with the particular interrupt source, which is the interrupt request, right, the IRQ, right? So basically there's a table somewhere, we call it the interrupt vector table, and it's a mapping between the interrupt request and the function that we want to execute as a result of that interrupt request. So we look up that function and we start executing it. We just run that function, we run it all the way through. Once that's complete, we restore the state of the executing context and go back to our main execution, and execution resumes like nothing happened. So as far as the main loop is concerned, there was no interrupt that was executed. Unless we go looking for the remains of that interrupt service, we're not going to see anything. And the remains might be like special flags that are set, or any changes that the interrupt service routine, that interrupt handler, might have actually executed or left behind on purpose. So there's two main approaches to handling signals that can happen at any time, asynchronous signals in software. And the first one is the most basic, and it's what we've been looking at so far with watching the button and stuff like that. It's called polling-based interrupts. And basically, we have a little loop, and it's constantly checking to see if some condition has been met, and then we execute some functionality when that condition has been met, right? And so we're using CPU cycles to do the check and to handle the check, right? It's not super efficient, and we could possibly miss those checks if the things that we're doing otherwise take too long. Interrupt-based asynchronous signal handling is hardware-based. So the hardware is the one that triggers. We set it up, we fire and forget it, and it runs off and it executes, and we never have to worry about it. And we're as long as we operate within some certain constraints, we are guaranteed to never miss a signal, because the hardware is the part that's checking, not the software that's executing. So we don't have to worry about the sequence of software. We can handle that signal whenever it occurs. So interrupts are really handy for handling things where the main thread of execution needs to continue, and we'll come back to it later.